let's turn to the summary output from our GLM object now. We've got the summary function, and we'll feed it the TPB mod, the GLM that we made, and run this. And we can see it looks very similar to the summary output from a linear model, from an LM object. We've got the call at the top, the kind of what we fed it. We've got breakdown of the residuals and the coefficients and everything. It's looking pretty similar, but there's a big difference between what this summary output is reporting and what the LM summary output that we might have seen before is reporting. Because, as you'll recall, this GLM, right, has a log link function. The coefficient estimates that we've got here, right, 4.38, negative 0.17, those are not real-world numbers. Those numbers are in kind of log link space, right? Those are on the log scale. They're on our link function scale. So, for example, the estimate of the intercept, 4.38, as we've said before, the intercept should be your kind of predicted value when the Krull index is equal to 0. But in this case, it's not, right? A Krull index equal to 0 does not mean that we've got a tibial measurement of 4.38 millimeters, because this 4.38 is logged, right? What we need to do, just as we did with plotting the GLM, is take the inverse link function of this value. We need to take the exponent of 4.38, right? Because this 4.38 is on the log scale, we actually want the exponent of 4.38, which is 79.83. That makes a lot more sense in terms of a kind of a measurement in millimeters for the breadth of the top of the tibia, right? Much more realistic value for a Krull index of 0 to have a tibial measurement of 79 than 4.3, right? So this is an important thing to remember when you're interpreting the coefficient estimates from a GLM summary call. That these are on the link scale. They are not on the response scale. They're not on the scale of your response variable. They're on the scale of your transformed response variable. And so when we're breaking this down, right, as we've done before, and you want to, for example, calculate, let's say, TPB mod. We want the coefficients, we want the intercept, which is the first one, right? Pull that out, we can see it's the intercept. If we're kind of just building our linear model equation here, right? Let's do TPB mod coefficient 2, which is the slope, the beta 1, the estimate for the effective Krull index. And let's predict that for a Krull index of 3, let's say. So for a Krull index of 3, we're multiplying 3 times our slope for the Krull index times beta 1 and adding it to beta naught. But of course, if we do it this way, we end up with a number 3.86, which is not on the right scale. Again, that is on the link scale. What we need to do is wrap this whole thing in an exponent function to take the inverse link function. And our answer is 47.557, which fits based on the plots that we were seeing before, because this is a negative relationship. It's important, though, to not only remember that you need to exponentiate when you're calculating things in your kind of equation here, but it's also important to realize that you can't exponentiate the intercept and the slope separately, right? The exponent of the intercept here, which I'm just going to copy down, right? This plus the exponent of the slope times 3, right? That's a different answer, very different answer, right? Because we're not paying attention to kind of the correct order of operations here. We can't take the exponent of the intercept separately from the exponent of the slope and then add them together. That's not correct. You cannot do this. It'll give you a wrong answer. We need to make sure that we're doing all of the addition, all of the kind of additive stuff of our model equation. That needs to happen first, and then we exponentiate the whole thing, all right, or the end result of that. This is what the predict function is doing, right? If we use the predict function, on TPB mod, and we've got our new data argument is a data frame of curl that is equal to 3, right? So here I'm kind of inside the predict function. I'm just making this data frame instead of before where I made a new object called new x, because here I just want to predict what it is for a curl index of 3. So I could just feed 3 in to this data frame within the new data object within the predict function. And if I say type equals response and run that, right, 47.557, what was the answer from our manual calculation? 47.557, right? What the predict function is doing is exactly what we just did. It takes our model, plugs in the value that we want to predict, does all of the calculations, then it kind of untransforms it using the inverse link function, which is exponentiation in this case because it's the opposite of a log. And that's what the predict function does when we specify type equals response. If, for example, we didn't exponentiate this, we just deleted that exponent part, our calculation is 3.86. The exponent of 3.86 is 47.557, which our predict function tells us. But if we take the predict function and instead of saying type equals response, we say type equals link, look what we get, 3.86. All right. On the link scale, the scale of our link function, a log scale, that's what this is doing. That's what we get when we don't exponentiate. But if we want to get this back into real world space, right, we need to take the exponent, right? We need to take the response scale value from the predict function. That's how we get things back into kind of a scale of values that we can actually interpret accurately and kind of better wrap our minds around.